Hello, my friends! I am back after incredible adversity. It is so good to be making videos again, and this mountain has really challenged our understanding. In the last video on this topic, in part 1, we saw this mountain from various locations, and I tried to look at it and photograph it from even farther away, but I couldn't find any good locations along the ocean. So I went up in the mountains of Tehachapi trying to see if I can observe it over the foreground mountains. And what I discovered was really shocking.
Okay, so I got a really cool system here. I brought my telescope. Got a new color camera, but it's highly sensitive in infrared. I'm very impressed with it. Really solid triplet APO telescope, triplet APO 80, about a 480 millimeter focal length. Great camera connected to my laptop, and I'm ready to look out there to see those peaks in a little bit better detail. So here we go. And then also I'm going to look at that direction, see if that's Mount San Jacinto. It's really faint, but I think it might be. All right, let's give it a try.
This little camera is simply incredible. It is a color camera, but it's highly sensitive in near infrared. And that's why I bought it. By putting an infrared filter on it, I can block out the lower frequencies and just use it as an infrared camera. And the sensitivity is incredible. Have a look at this chart. Notice the sensitivity at 1000 nanometers on the right side. Wow, 40%. This is one of the best cameras that I was able to find that's not over, thousands of dollars. I think it was only about $100 or so, maybe $300, I don't know. Just a few $100. I am really pleased with this camera, and I'll show you how well it does in a second. But I also brought my old Sony camera so I can take some photos. So this is with my Sony handheld camera. This is Antelope Valley. We're seeing the mountain range separating us from LA, Southern California, somewhere in that direction. And so the ocean is somewhere over there. And this is there's some hills over here, but it's flat way out there, and Mount San Jacinto should be in that direction over there, and it wasn't quite clear to me. I didn't quite have confidence that I'm seeing it. The mountain is 10,800 and those hills are around 6,000, so you would think the mountain would just stand up and be clearly visible. But I began to wonder, what's going on? Is that really Mount San Jacinto there? Wow. It would be incredible if it is. Kind of looks like it. So here's a snapshot. So this is the reason why I brought my telescope with the camera, because I can zoom in and you'll be blown away when I show you the footage. But this is with my Sony camera. Nice shot, and I wasn't quite confident that that's Mount San Jacinto at the time. So I came out here a few times before, and I was amazed because when I went flying from here, it seemed like Mount San Jacinto all of a sudden popped up, And there's weird phenomena going on with refraction. But let's have a look at this incredible footage through the telescope. When I first laid eyes on this mountain on my computer screen, I could not believe it. It is Mount San Jacinto. Unbelievable. Here on the screen it's flipped left and right horizontally because that's how the optics work with the sensor. So for the clip that you just saw, I flipped it horizontally. It was quite a shocker, folks. Yeah, it is Mount San Jacinto in that direction, but it's so low. Unbelievable. Why is it so low? Well, an analysis reveals a shocking truth. I have taken a number of frame grabs and I assembled a bigger picture. Have a look at this. I had to know what I was dealing with, so I went to Google Earth and tried to identify the peak on the left with antennas. And so I put a line down between Mount San Jacinto and my observation location. And so there's the mountain. And then just 40 miles away, there's a peak that's very close to this line of sight, and it's Strawberry Peak, and it's at about 6,000 feet elevation. Wow, that is incredible. So let's do a comparison now on the infrared image. Have a look at this. This is incredible. Mount San Jacinto is at an elevation of 10,800 feet MSL, mean sea level. Just incredible. And just 40 miles in front of it, here's a peak, Strawberry Peak, and it's only 6,000. Wow, in 40 miles? Really? We lost like almost, 5,000 feet? Wow, that does not check out with the Earth's curvature, you know. There's more going on here. Obviously the observation location, etc. But we are really watching refraction, heavy refraction at work. It's bringing this mountain low, you know, if it's really 10,000 feet. And I kept, wondering, I mean, when I measure it with a theodolite, it appears to be 10,800 feet, assuming the coordinates given in the spherical coordinate system of the globe, you know. But when you compare with other mountains, it doesn't quite check out, and it gets really strange. So imagine my shock when I went to Mount Wilson and I brought my theodolite. I said, I'm going to measure it from Mount Wilson. And wow, that's coming up next. Stay tuned.
Wow, look at the observatory. So huge, man.
A trip to the Mount Wilson Observatory can be quite rewarding. There's a lot to see, and the views are just breathtaking. Mount Wilson is located in Southern California, up at about 5,000 feet, and there's hiking trails around. Here's a map of where it's at. So my observations were taken from about 5,600 feet in the parking lot by the Cosmic Cafe, I guess it's called. You can also grab a bite to eat. If you go during the day, you have to get a parking permit. But if you're there right before 5 o'clock when they close, sometimes they tell you you don't need a permit, just for an hour. So, if you have the chance and you live around here, I highly recommend it. I browsed their website and I discovered that's where we discovered our place in the universe. Wow, okay, whatever. It was founded by Mr. Hale, apparently way back in the early 1900s. There he is. Smart guy. He's wearing glasses. You gotta be smart if you wear glasses. Anyway, let's have a look at my video footage from up there because it is quite shocking.
Oh, look at these antennas. Crazy. Well, Mount Palomar here. Got my scope and I'm looking at Mount San Jacinto. You can barely see it. It's almost at the limit. Sometimes the clouds pass and it's clear, but it's about 89 and 5220, which is really weird.
The top measurement is the vertical angle measured from zenith, and so we're slightly above the horizon here, about 8 arc minutes. As you'll see shortly, that's just really incredible. Here I've adjusted the levels and you can barely see the mountain. So we're pointing at the peak, but this haze is really annoying. But I triple checked and I was pointing at the peak. Here's my infrared camcorder. I brought that along just to, verify that I wasn't dreaming, looking at hazy peaks in the distance, and that's the clip we saw in the intro. I just love my Sony camcorder. So see, there's a lot of haze, and can barely see it. I'm not sure how it's going to come out in the YouTube video once it's compressed, but you could barely see the outline of the mountain. And in infrared, wow, infrared is just amazing, as we've seen. You can just pierce through the haze and see things clearly. And if I adjust the color, saturation, and the levels, wow, we get that really neat infrared imagery we're all used to. Look at that. Wow. Mount San Jacinto from the Mount Wilson Observatory. Just incredible. So earlier we were seeing it from the left side, looking at those at that rocky face there. But look at the mountain. It looks so tiny and small compared to, this mountain that I am on. Yeah, Mount San Jacinto looks really small. It's crazy. Now here's the analysis. Unbelievable, folks. The height of Mount San Jacinto comes out to 6,666 feet. Unbelievable. So this elevation matches this observation. Just incredible. We have two pieces of evidence here that seem to indicate this mountain is not the height that is published. What is going on? This is dangerous. Imagine you're flying, and the question is, should I trust my altimeter? Yeah. Well, the answer is yes if it's set correctly. But this is very disturbing. This image was taken by me um, from the backside of Mount San Jacinto when a storm came through and the snow level dropped to about 3,000 feet, maybe a little bit below it. And just a rough analysis here kind of also correlates to the peak being about 6,000 feet. Just disturbing. I mean, this really took me by surprise, you know. I said, what is really going on here? So let's have a look at what I think is happening. Southern California is incredibly flat, so that's the red line, okay? So in one coordinate system, this mountain has a elevation of about 6,600, okay? But in the spherical coordinate system, the green, right, you start at the ocean, mean sea level, and it's curving away theoretically, and that's based on observing things dropping in the distance, which is really a refraction phenomenon, not that the surface is curving, and we'll illustrate that shortly. But as a result, there is a difference between the two coordinate systems that you see there. So this is the reality, folks. If you've seen my previous videos, due to the angle of incidence through the gradient, steeper propagation angle affect the path of the light the least. So in this graphic, notice observer 1 is farther away, and the curved path, the red, that's the path that the light takes, curves upwards. Okay, and the observer perceives along the dotted yellow line. That's how our minds work, right? When you look at water and you see fish in there, you assume it's in a certain direction, but there's refraction. So if you're spear fishing and you go for where you perceive the fish is at, you're not going to hit it, okay? It's the same thing here. There is a refraction in the atmosphere, and our minds perceive along the dotted line. Observer 2 is much closer, and the light from the mountain propagates at a steeper angle towards the ground, and it experiences less bending due to Snell's law. The least bending is when it propagates up and down. Okay, and now the perceived height of the mountain is closer to the actual. So this is really the reality of what is happening in our world. What we see is not accurate, and it depends on the location and the direction. We live in an anisotropic medium. To really illustrate this phenomenon, have a look at these infrared images I took from Site 1 and 3 that I showed in Part 1. One was taken at 123 miles away and one at 47 miles away, along almost the same line of sight. And I've aligned the peaks, and here we see the effect of refraction. Just incredible. Have a look. So here's 123 miles away and then 47. Look at that. So notice the peaks are aligned, but on the outskirts, notice how the angle changes. So see, light has to propagate longer at shallow angles, and it hits the ground, and we don't see far because of that. So it's really this refraction that's occurring upwards, totally contrary to what science says, based on the globe model. If you believe you live on a globe, then they believe light is curving downward, but it's actually curving upwards, as we can prove using Snell's law at steeper observation angles. Just incredible, folks. If you haven't seen my previous videos, I encourage you to browse my videos, and please do subscribe. We live in an incredible reality, folks. It just boggles the mind. in part one of this video, I showed this image and I calculated about the same height. Now, some of you corrected me and pointed out to the fact that the windmills I identified were actually much taller. And I was able to go out there and verify that indeed that is true. So that was a mistake on my part, but I'm not sure I took the image from what I thought I did. And so the jury is still out on this one particular image. I was trying to use the height of the windmills, but this alerted me to the fact that something is not right with this mountain. And of course here we're doing pretty steep measurements, and of course the windmills on the bottom could get amplified. The image is stretched due to refraction, so our reference in an image can be amplified on the bottom and it throws the whole image off. I've observed this many times at shallow angles, and I'll show some of those videos from Hawaii. I filmed from the Big Island to Maui, and this phenomenon was so pronounced. It was incredible. But thank you for pointing out that mistake. And as always, I welcome comments. Be courteous. And thank you all for all the encouragement. I went through a lot of changes in my life. I moved out of California. Yeah, I almost died from the virus. You know, I'm so sad to hear that Rob Skiba passed away. Just broke my heart. I looked up to him. But yeah, there's a nasty virus out there. I suffered for 8 days on the brink of death, but I did not go to the hospital. I just tried all the home remedies I could and coughed, and my body was hurting. I thought that was it. I was done. It was the worst flu-like event I have ever had since childhood. Anyway, thanks for watching everyone, and don't forget to like the video if you've enjoyed it, and do leave a comment. God bless all of you guys. See you in my next video.